Do you ever have one of those moments where you just get frustrated with yourself? You know, you just have a grumpy ass day. That was me yesterday. And I had my phone on silent most of the day, dealing with other things other than here. And my first phone call I returned yesterday, I'm like, yeah, man, I seen you call me like 4:30 in the morning. What do you want? I was a complete dick. I had to call that guy first thing this morning and say, dude, I'm sorry. I didn't mean to be a childish douche. Here I am preaching to everybody. Don't be a dick. Don't be a dick. All right. So we got that out of the way. First things first, last things first, third things last. Safety always third. Unless it comes to safety squints. Look, safety squints are a thing. You have to use them. They haven't come up with a good replacement eyeball system yet. Teeth, no big deal. Fingers, for the most part, they grow back or you learn how to do something else with them. Your eyes and your dingus. Yeah. Whew. I'm telling you. Okay, safety squints. And Kevlar cup. I am looking for 1.25 inch heliacs. And I've already hit up all the usual coax crack dealers. So I'm looking for the guy that's got a spool of 1.25 inch coax sitting next to his house that he might have snibbed from a cell phone site or something like that back in the 90s. I'm looking for 1.25 inch, not 1 5/8. The shit's too stiff, can't bend it. I'm looking for 1.25 inch heliacs. I'm doing a huge antenna overhaul this summer. New tower, new beam, and I'm tired of running my amp on low, which is where I've been now for 3 years. I was on low mode, and I want to see where the thin air is at. I want to turn the box up. Well, for me to do that, I have to start accumulating 1.25 inch fittings and 1.25 inch coupling plates, and first I need to go find the coax. I have got a small fortune in RG 218. I love this stuff because it's super flexible. It's very easy to use. I've probably got 400 foot of it here that I have accumulated over the years. But I have come to the realization that since my amplifier's basically got the power of 315s or 2.25 20s, I need to think about doing something a little bit different for coax. So 1.25 inch is about as big as I dare go because of my antenna situation I have over here and having to not be able to drag the stuff around on the ground. So, but the reason that you're here and I'm here has nothing to do with that. But if you have a pipeline that isn't like Derail and his brother or the usual coax guys, because I've checked with all of my guys, 1.25 inch is getting really hard to find. The fittings are getting incredibly hard to find. Here, I'll give you an idea. This is what I'm after. This is what I'm on. This stuff will disintegrate. This isn't quite big enough. This is 7/8. This is RG 218. And I'm here to tell you, I've put 30,000 bird through that piece of coax now for almost 4 years. I'd go to 7/8 heliacs. I'd just rather have the buffer of 1.25 inch. So, anywho, next things first, second things last. Maybe I won't screw up like I did on my last YouTube video and put my extra as my intro when I'm doing my video editing. And I can actually successfully succeed. We are here today, you, me, and all of my other subscribers, to look inside of this little gem of an amplifier. This is a Fatboy. I don't know all the complete history on this box. It come from my buddy Mr. R down in California. He sent this up a long time ago in a galaxy far not too from here. And it got put on the shelf and sat here forever. I'm pretty excited because I'm getting down towards the bottom end of the pile, you guys. The goal is to be 90% completed with the mountain of work that I have. Oh, shit's rolling around inside of this thing. Listen to this. That's never good. We successfully worked through the mountain of pile of stuff that I have over here. So come in September, as the game plan has been now for over a year, that I can take on more projects for you guys. It's my goal. Gotta have goals. Okay. Fatboy produced these for a long time. This is a Fatboy straight 4-pill that I guess was supposedly fixed by them, but this doesn't look like their handiwork. This is what's flopping around inside the box. A 100 ohm balancing resistor. Gee howdy, I wonder where that came from. This has got their little voltage regulator for the fan. I'm not familiar with them using these little clear plastic fans, never cools. This has got 1446s in it, 4 of them, the SD version. It's been repilled by somebody that isn't that gifted with an iron, but the connections at least look legit. Our 100 schmohm balancing resistor here has been replaced, and this 100 ohm flyback has been replaced. This is a APC battery backup power supply transformer that work lovely as 12 volt power sources. I have lots of these here. I have a friend of mine that's in Arizona that buys these things for me. I have the, 6 out of the 200 amp versions, and I think I got 6 of the 100 amp versions also sitting here. But these work well. This is Fatboy's handiwork, but it's been reworked by somebody else. So I can't like point a finger at them, but I can say they are the guys that built this originally. There's nothing wrong with that. A lot of loose solder flick and aluminum and shit falling out of this thing. Well, I'm gonna put this on a variac and bring it up real slow. Let's see what happens. Do 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 do. I could just plug it in and slam it to the on position and we could see what smokes, but it's been sitting here for so long. Well, we don't know. We don't know. I'd rather bring it on slow. So if we had a catastrophic failure, we can see it unfurl in front of our eyes slowly and maybe stop it before we have massive damage. Is this absolutely necessary? Yes, would be the answer to that question. We don't know if our electrolytics dried out in the last year. We don't know. We don't know. I called the guy, I said, hey, what's the deal with this? He goes, it don't work. I was like, oh, aren't you a vestule of knowledge? He goes, no. I paid them to do this and this and this, and it didn't work when it came back. And I was like, okay. I said, do you remember anything else about it? He goes, nope. I said, sweet. Here we are. So, voltmeter in DC. The switch I do believe I have in the on position, AM, off, and sideband. That's cool. I got a disc capacitor. What is it? It's a 0.01 going from the AC rail for the transformer. Not vital. Leave that in the on position. And Quantec. Okay, no love there. There we go. Oh yeah, we're gonna be fine. Oh yeah, we're gonna be fine. So we're at 85 volts on the variable step transformer here. First one of these I ever worked on was Nice Guys in Salt Lake. And he's broke it about a dozen times since then. But he's down to the point, he's finally to the point where he's able to change the transistors himself. Winning! So good for you, Nice Guy. Appreciate you, buddy. Aaron's my friend. I really do like Aaron. He's a good guy. Very good man. So what do we got for leakage? None. That's a good sign. Okay. Now we've hit it and we quit it. Let's clean this mess up. And let's see what's not working with it. Preamp works. This is a primary on-off switch. I've never known these guys to build with this switch, so we know that this is aftermarket. AM, off, sideband. Do 1 2, tickle your shoes. Turn on our peak kit, put that at 0. Oh yeah, let's show some units of measure here real quick. 1000 watt, 1000 watt, 5 watt. Okay. You gonna work for me today? You are. I took this all apart after the last video where I had to smack it. I can't stand doing shit like that. I can't. I took it all apart. I can't find nothing wrong. All my connections are clean. Everything's making contact the way it should. The meter movement tests good. I don't know. I don't know. The only thing it can be is on the inside of the pickup down here where the element makes contact inside the hole. Pardon me. Inside the hole, there's a little pin that sticks through the side of the coupler that touches the element. And there's 2 ports on the element. So you have this little slot here. You have this little slot here. Then 180 degrees out, you have this little slot here. And a little wiper arm inside the line section makes contact with that. Actually, it's this, and then you flicker this. See what I'm saying? That's how we get the girls to go home. So it makes contact with this. So when the element is reading in one direction, it's making contact with this connector, but then when we rotate the element around, it makes contact with this connector. The proper way to clean these, believe it or not, is with a dollar bill. Take an old, not new, old dollar bill that's really soft, wrap it around your finger, you stick it inside this hole, and you clean the contact. It's silver plated. And over time, you can get a dirty connection. And every once in a while, that connector, that finger stock, gets bumped and it won't make good contact with the element. We're working today, as we can obviously see. So let's go back to auto, and bink, everything's in focus. Okay, as we can clearly see, everything's working. We're going to put about a half a watt of carrier in it. With a half a watt of carrier, it makes 4¼ watts. Hello, tickle your shoe. Hello. Hello. Everything is working, but the input tune is deplorable. Our sideband delay is working. Hello. Hello. Touch your pee-pee. Hello. This thing's working perfectly. All the transistors are lighting up and heating evenly. None of our output capacitors are wobbling around bad. Our input voltage divider that's here is not heating up. Our balance resistor on the output is not heating up. Relay's clicking. Hello. Ooh. Amp is off in the OFF position, right? Let's look at this. What happened to Stewie? Where'd the other Vader go? Oh man, I got Vader down. I got a Vader down. Man, son of a bitch. Hold on. So, all these little toys, and guys, don't send me any more toys, please. I've had friends and fans send me all of this stuff over the years, by the way. And they all know who they are. From this guy here. Yes, even the pill bottle is from a fan, a very good friend of mine. The pill bottle is shavings off a transformer that I sent to my friend. This is before I had a bandsaw. Oh, this is just getting better as we go here. I didn't have a bandsaw back in the day. And so I had a friend of mine that had a bandsaw. And I had a transformer that the transformer core was like a 1/16 of an inch too tall to fit inside of a cabinet. So I took it to his house and we shaved off that 1/16 of an inch. Well, him being a neat freak that he is, he saved all of that for me. Oh man, I broke it. He saved all of that for me. And then put it in a bottle, wrapped it up in this giant box and gave it to me for Christmas. So that bottle actually showed up. This bottle actually showed up in a box about the size of the old Samsonite suitcase over here. And he gave it to me. But I've had different customers and fans and stuff send me this stuff. Please don't. I don't have any more room for any of this stuff, you guys. I just don't. I'm out of room. I'm out of real estate. Okay, so back on topic. 2950 going through the box to the dummy load. Hello. So we're putting 5 bird through this amp. Hello. We're getting nearly 2 bird back. And that's just talking through the amplifier. So that's a measure of resistance. What I'm showing you is the measure of resistance of the RF simply going in and then coming out. And the measure of resistance of just this here. And usually it has something to do with this preamp circuit. There's a huge impedance bump that takes place right here, and people get fixated on just making the preamp work, and they don't want to take care of the impedance bump that's here. I'm sorry. If I'm putting 5 in and getting 2 back, that's like an SWR of 3.5. 4.4, 4.25 something. I got a chart around here someplace. There it is. So let's see here. If I'm putting 5 in and I'm getting 2.5 out, or two coming back, that's an SWR of 4. So 5 in, right here, that's 5.0, and 2 back. The 2 lines merge right here, so it's a 4.2. It's horrible. That's horrible, I say. Just horrible. Let's fix that and then we'll move forward. That was simple. Why is this so important is what you're asking yourself right now. I've explained this before and I'll cover it again. The reason it's important that your ability to be able to pass RF through the box from your radio out to your antenna with the least amount of resistance as possible is because the RF flows in 2 directions, gentlemen. It comes from the radio through the amplifier and out to the antenna, but then the RF has to come back down from the antenna through the box to the radio. And if you don't have almost a seamless impedance bump here at this particular junction, along with all other amplifiers or any other thing that you put in line, the RF no want to come into the radio, so you cannot hear and make you deaf. Your head would be up butt, ostrich with head in sand. Amplifier beyond can't hear nobody 3 miles down the road. There's a give and there's a take. This particular amplifier, 9 times out of 10, how we match that impedance bump, that shift in resistance, okay, is that we'd add a little bit of capacitance. Either it be on the input or the output side of the relay. This particular box, it wanted a little bit longer wire. I think I already pitched the wire. The wire length that was in there was about yay long, which is generally what you want to do. You generally want to have the shortest wire lengths that you can. Anything that's mucking with the relay connections. When I went to add capacitance, our input our pass-through SWR went up, which told me that it needed more what? How do we offset that impedance bump of capacitance? If the circuit is already too high in capacitance, either we can reduce capacitance in the circuit to bring that resistance down, or we can increase our inductance or increase our inductor length. So instead of having a wire that was about yay long, I went to a wire that's about that long. Every one of these things hanging up on this wall means something different to me. Every one of those little pieces of Vaders, they've come from different guys that all have different meanings to me. So everything that's up here kind of looks like a collage of shit, but really it all means something different to me. Here's our pass-through SWR now. Hello, 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 1, 2, 1, 2, 1, 2, 1, 2, hello. Instead of an SWR of 4, let's get out our chart from Martin Electronics, which copied it from the Bird chart. Let's see. Survey says, if I have 10 watts or 5 watts going out, and I've got 0.2 of 1 watt coming back, that means my SWR is lower than 1.05, which is totally cool. Now how this chart works is this number on the bottom goes to 500. Well, this chart means that we can read it in integers of 5. So 500, 5,000, okay. We can do it in integers of 5. 5, 10, 15, 20, 25, 30, 35, just by extrapolating out the zeros. But if we want to keep it in easy math for most people to understand, we can do this in 500, 5,000, and 50,000. And this chart and the math on it stays true. So let's say my station with a 50,000 watt slug, and I'm putting, we'll say 35 kW out, or 30 kW out, which is the 30 mark here. And I have, what, 5 watts of reflect with 30K going out. That's down below the 0.02 mark. That's below the 1.05 number, just by adding some zeros. It's pretty cool. Pretty cool. Remember, on this chart, if we add zeros here, we have to add zeros in front of the number here. Okay, so that 25 watts is going to be 0.2 at the beginning of the chart. 0.25. It's an exponential thing. So, never bothered to look at the back of this. Lay your arranged cross scales. That's kind of cool. Come back to that later on another video. So we've got our pass-through SWR fixed. Let's go ahead and let's see if we can get our input reflect to come down to something normal human species would like to see. Let's take a look again up here. Hello. It's not horrible. Now that we've fixed the input impedance bump. Remember, as the RF came in, it's got to go through that preamp circuit. So by us taking, remember, our input SWR or our input reflect was at about 3.5 watts, 4 watts. Now we're down below 1 just by adding a little piece of wire to it. So, hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. All we did was move this little trimming capacitor here. So we flattened out the curve, as they're so much loving to say in the news. I can't watch the news anymore. I just can't. God dang, I can't. We flattened out the SWR curve. Now this thing is filthy on the inside. So I gotta wait for the sun to come up. And I'll fire up the compressor and we'll blow it out. We'll degrease it and stuff. But with, about 15 going in, turn on the bench supply to bring the voltage up a little bit. Waiting on them supercapacitors to charge. There, we're at 14.5 now. About 20 watts. Amp on. 1 2 1 2. Now we're up to about 425 watts, which is about all this thing should do. It's got 4 60-watt transistors in it. Simple, easy peasy, right? So now I'm standing here, since we've proven to ourselves this thing works. I'm standing here looking at this dusty old girl, and I'm like, well, what can I do to modify this to make it a little bit better? And I sit here and I look at where all the shiny bits are at, because the rest of this thing is dirty. But then I ask myself, why are these shiny? And then I look at the capacitance value, and they're 1000s. To me, that's a little bit high with this transformer, and there's things that dictate what this capacitance is going to be. And just over the decade of doing this now, I look at this and I think to myself, these transformers at this size, with this number of turn, at this size of wire, with this amount of surface area on the transformers, should be closer to the 800 department, or possibly even as low as 640, taking into account we're running SD1446s and we got 330 puff capacitors on the side of each one of the transformers. The circuit makes a little bit more sense to me that way. But we've got good input SWR. We've got good input SWR. And the circuit's running stably. These capacitors aren't getting too hot. I do want to change out these little tiny chokes though. I need to clean it. I'm going to think about what I want to do here. It needs a bath. It needs to be run through the douche flute. I washed it. It got the old douche flute job. It's all cleaned up now on the inside. Took all the filth out of it. Washed the board. Got all the schmutz. Oh. Off the front of the heat sink. Got all the filth out of it. Got off all the dirt off all the parts. We're gonna put some fingernail polish on that tuner so it can't move in shipping. Did a little power wire upgrade to it. Changed out all the resistors so they would match. I got one more thing I gotta do to it. Let's help it stay clean. There we go. Done. I soldered the power leads on the filtering capacitor over here. They were just crimped. And that's about it. The other thing I did is I got rid of the Never Cool fan. Throw that in the trash. Got rid of the Never Cool fan and put a decent JMC in here. So this will actually move air through the box and keep it cooler. That allows us to have a little bit more key down time. The other thing I did is I got rid of the 1000 puff capacitors and went down to 720, which made it do this. So everything stayed the same. Show you what we're doing here. Hello. Hello, 1 2 1 2. Hello. Now that is interesting. My pass-through tune jumped up again. What happened? Hello, hello, hello. Let's revisit that. That is interesting. Somewhere in the process, something has moved here, and now it's not happy. And it's showing up over here as it's eating half of the power as I'm talking through the box. That's bad. That's bad. Let's go back and revisit this section again over here. Man, I'm glad I paid attention in amp school. Okay, first things first is this coax connector is junk. So I couldn't seem to get a good connection reliable with the PL259 connector, so I changed that out. And the other thing I noticed is that this cap was now touching the case, so I moved that, but I couldn't get it like quite exactly where I wanted it to be sitting. It was sitting at like a 1.3, which is still not the greatest, but not the best, and I was shooting for something a little bit higher than that in quality. So we're going to look at our grid dip analyzer here, and we're going to look at the red key marker here, and that's associated to this upper frequency, 27.025. It's now currently sitting at a 1.1558, fluctuating 5.9. So what we're looking at is the RF coming out of the analyzer, coming in through this coax connector, going up through this wire. It's got this disc capacitor that is in series with this diode, which is in series with this capacitor to ground. So the RF comes in the standby position, which we're currently in. Okay. Then it comes out this connector on the relay, and then it comes down here to the blue relay. Well, attached to that blue relay is a little tiny disc capacitor of 10 puff that is shunted back to ground through the keying transistor, which is down in here. buried down here in the bottom. Well, I got low battery on my analyzer. You can put up with it. I'll charge you in a minute. So first I thought they might have had too high of capacitance on the disc capacitor back here stuffed behind a relay. No. It's the right capacitance level. That happens. It's happened to me. Reach into a drawer full of capacitors and you think the drawer's got a bunch of 10 puff caps in it, and you know, just maybe 100 sneaks in there, or maybe a 75 by chance. So I pulled it out and verified that, and no, that's not the issue. And so then I tried adding a little bit of capacitance on this side. So the RF goes in, goes through the contact links on the inside of the relay, and I got a clear one here. I can show you how this works. Sorry, I should have had this pulled out beforehand. My apologies. So all this is different inductor links, right? So that's why I hate preamps. They're so vulnerable to input issues. Okay, so this is the same relay, but it's clear. So the wire, the RF comes in on this post on the back side. It's got to go up this length of conductor on the relay, through the tab, and then back out through this tab and all the way back up here again. It's got to cross over this connector and then back down again, and then back out this post, which in turn allows it to go up to here, and we come back to here, then we go through the relay, and then we come back around, and then we go over here to this coax connector. Then we come back down, and then we come here to the coax connector to go out. Now every one of these takes just a little bit more tweaking to get it just so-so. The wire lengths are different. The capacitor values are a little bit different on most of these. Some of the time the preamps will come in here and they're not all screwed up. This isn't the case. When I talked to the customer this morning, he explained to me that straight out the hop the thing was bag of dicks. Those are his exact words. I think you might like to watch my YouTube channel. And nothing worked right because I couldn't talk through it. I couldn't talk into it. My SWR light kept going off on my radio when I talk through it or talk into it. I'm like, okay, I understand all of that. That all makes perfect sense. So no matter where I added capacitance in this chain, wherever I had access to it, and you can only add that at a switched point, because when the circuit becomes live with input RF, you've got to make sure that that circuit is balanced. So you can't have it, like I can't add capacitance on this lead. I can't. Okay, but I can add it where it's going to be jumpered through. Like I could add it here if I wanted to, or I could add it down here, down back in here if I wanted to. But the number one place that I wanted to add capacitance was on the shorting bar. Well, there was a shorting bar that was in here, and I removed that and I replaced it with that inductor coil. That coil is paramount to making this thing have that low of a shwoo at 1.15. We're desperately needing that. That's the whole reason that we're spending all this energy and effort, is we want to get that down below like 1.3 or 1.28. Guarantee that we'll be able to talk through the box. Well, no matter what I added for capacitance, like I said in the previous segment, the input schwirr, pass-through schwirrs were going up, which was telling me it already had so much capacitance in the circuit that it needed more inductor for it to come and be balanced at 50 ohms. So I went ahead and I did this little 4-turn coil, 3-turn coil on the pass-through relay. So when the amplifier goes into operation, so right now the relay is sitting like this. It's switched to these back posts. So when the amp goes into operation, dink, this wire moves over internally, the connector moves over, and it hooks up to our output combiner transformer, and then it jumps over to this piece of coax that runs down and goes up the front of the box. So the only place I can add inductance was right here. And so then you have two places that you can add inductance, pre and post induction coil. Okay. Well, This thing is happy if I added exactly 40 puff worth of capacitance on the input side and then preloaded with the inductor coil. So we can adjust our input SWR, or pass-through SWR, by changing this coil. Check it out. That's me just putting the screwdriver inside the coil. Out. Touching it. Pushing it closer together. Or a little bit farther apart. See how that works? Any good radio amplifier technician understands how these laws and principles work. It's covered in many, many books. Nothing complex here. It's just a lot of little hung together, hanging out, floating in free space parts. You just got to be able to think through the circuit. Because I guarantee you, you're not going to find a schematic for this particular circuit anywhere on the inner boob. Okay, moving on. Finally, thank Jesus. I just literally got off the phone with a guy not just 2 seconds ago. And he says to me, you know, what you're working on is really basic electronics. And I said, yes, I totally agree with you. I said, the only thing that makes me special in this world is that I have the ability to explain it to others and not make them feel stupid. So, is what it is. Basic electronics. Input tune thoroughly covered on this thing. It's all cleared up. Power wire's done. New fan. Partridge in a pear tree. So now, if I remember correctly, with us putting 20 watts of drive into this thing when we started, and this is a 50 watt max box, by the way, 50, maybe 75 at the most. Oh, I gotta take this. Okay, we're gonna try. We're gonna try and make it through this segment without the phone ringing. Okay. So where we left off, 20 watts of drive, making 400 watts of power. Let's see what we get now. Man, I thought it was square. I apologize, YouTube land. There we go. Okay. Hello. 1 2 1 2 1 2 1 2. Here's our input tune now. Hello, 1 2 1 2 1 2. Hello. Hello. Got down. That is all tuning. We didn't do anything magical inside the box other than make sure everything was balanced. We didn't change the voltage. We just got our input tune right, and we got the ability for the RF to come into the box, and because of the good coax connector, come out of the box, and then we made it so that we can talk through the box. That's it. Everything's working. I'll leave it alone. Well, guys, that's it. We're done with this little 4-pill. It's ready to go home. Not be here no more. Run it away, pack it up, send it off down the street. Well, gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. I don't know what bragging rights that really gets me, but if you're tuning in, I got to tell you, if you're trying to follow along with me on Facebook, you guys need to come join BBI Amps, the group. We've got over 2,000 plus members as of last night. Haven't bothered to see what we got going on today, but Facebook has got me bottlenecked where I cannot take on any more friends. I got 999 friends. I can't take on anything more than 500. If you send me a friend's request, it will not be responded to. I cannot add you. Come join the radio group. So far, it's turned into a really, really busy interactive forum. People putting up pictures of their station, people asking questions. It's another avenue to be able to contact me. Come join the group. Just tell you. BBI Amps. It's probably on the screen right about in here. if I'm any good at my job in the editing department, which we all know I'm failing miserably at here lately. So on that note, big thanks to every single one of you guys. Shout out to Siglet, big shout out to Excess Power, big thanks to Berg Coaxial Dynamics. Till the next one, we'll see you.